Hi friends, welcome to this lecture. In this lecture, I will introduce you with the instruction set. This is the first lecture of second unit instruction set of Intel 8085. Every microprocessor has a fixed number of instructions that it can execute, and that is called as instruction set. Again, this instruction set is a microprocessor specific. Microprocessor specific means instruction set of one microprocessor cannot be used for other microprocessor. So, outline of today's lecture is like this. We shall see what is the meaning of instruction, what is the program, and what is instruction cycle, then fetch cycle and machine cycle, and if time permits we shall see some diagrammatic representation of instruction cycle and part of some instruction cycle. So let us study what is instruction. Instruction is actually command to computer for specific operation, and just I said, every microprocessor has its own instruction set. Then you have to write program to perform a particular job, particular work, right? Program resides in memory, usually RAM. Program is actually instruction written in a proper sequence for a given task, for a given job. These instructions are stored in memory along with the necessary data in location 1, 2, 3, 4, 5, 6 and so on, and every memory location there is a 16-bit address. Okay. Then microprocessor execute these instructions one by one after the one in sequence till the last instruction of the program. One instruction may have several subtasks. The subtasks of a complete instruction are called machine cycle. Like machine cycle can be opcode fetch, memory read, memory write. So these are the subtasks. That means instruction cycle is actually fetch cycle and execute cycle. So let us study what is the fetch cycle. Just as I said, instructions are stored in memory location. Instructions have different size. It may be of 1 byte size, 2 byte or 3 byte, and accordingly it takes time for execution. So what microprocessor does is that execution of instruction means there is a fetching of instruction. To fetch instruction means giving out the address of that instruction, fetching the operation code, that is the instruction first part, and it is decoded in the instruction register of the microprocessor, and after decoding that instruction then it may perform reading the memory or writing the memory and perform specific operation, designated operation indicated by the operation code. So instruction has two main parts, opcode and operand, and here instruction cycle has two main part, that is the fetch cycle and execution cycle or execute cycle. I am using this word cycle so time because program execution involves a lot of instructions and instruction fetching and sub part of the every instruction, and you know that cycle word is used wherever certain process is repeated so many times. So necessary steps carried to get data from memory or storing a data to memory is called the execute cycle. In execute cycle, microprocessor generates particular set of control signal, and therefore the bottom line is that instruction cycle is fetch cycle plus execute cycle. Then instruction cycle requires different type for execution depending on its size and the kind of operation. Now I want introduce a concept of clock and t-state. In first unit we have discussed that all the operation of microprocessor or computer are time coordinated by a common time base. We call it as a clock. Actually, clock for a computer is nothing but a free running square wave oscillator which has a specific time period. One time period duration is called as 1t, 2t, like this. So when I say that particular task requires 3t, means you should understand capital T, that is the time period of that oscillator. For example, the microprocessor trainer kit which you are going to use in the laboratory has that 1t equal to 0.33 microsecond, right? So this is required to explain and to understand how much time particular instruction takes for execution. So that's why the T. So we shall consider one example so that you can understand the meaning of this T and how it signifies the length and execution time. Okay, so let us consider one example. I'm giving one example here, the instruction that is MVI. This is this move immediate accumulator 3-2. See, this is the instruction. The purpose of this instruction is MVI. So something is to be moved to the accumulator, and what is to be moved is given immediately after this opcode. So there is opcode for this 3A. Move immediate. The opcode for that is a 3E, and what is the data? 3-2. So here you can see this instruction MVIA 3-2 requires 2 bytes, and this instruction resides in the RAM, that is memory, and this timing diagram is for this instruction. So you assume that along x-axis horizontal is the timeline. Okay, now see here, this is the clock, this is the T1, first T, second T state, third T state, and so on. So you can see that this instruction requires about 4 plus 3, 70s, and therefore it requires about 2.31 microsecond to execute. You know that 1 microsecond is 1 millionth part of 1 second. So it is a very small interval time. Now see how it executes. The program is in the memory, and the microprocessor reads. How it reads? We have seen this, that microprocessor issues 16-bit address of memory location. See here, this A15 to A8 is the high order address bus, and AD0 to AD7 is low order address bus. These together 16 line issue the address. See here, on high order lines it issues 20, and here it issues 00. So together it represents 2000, and this is the address of the first byte of the instruction. Once again, you note here carefully, high order address is available here on these 8 lines for 3 clock duration, and low order address is available, which is 00 here, only for 1T. See, and that's why we have to demultiplex the address data bus, which we have studied in last year. See that again, during the first T1, ELE goes high, that latches the low order address, and after T1 the RD bar goes low because microprocessor has to read the content of memory location, right? See that here. Once again I repeat here, see that during the first 3 clock, high order address, that is 20, and low order address 00 is issued by microprocessor. ELE goes high, and after one clock transition RD bar goes low, that means memory read. So when the RD bar goes low here, this data 32 is read, and see that here it is 3 not 32 exact, 3E. So 3E is read here, and 3 is the operation code. It indicates the operation that the second byte, immediate byte data is to be loaded, that 32 is to be loaded into the accumulator. But where is 32? 32 is the address of 2001, and therefore after this first machine cycle it issues again the address 2001, the next address, and ELE goes high. So when the address 2001 is issued along with ALE address latch enable, this location is selected. Once again in the next clock the RD goes low here, and therefore this 32 is read by microprocessor, and that 32 goes into the accumulator. So the purpose of this instruction is that here 32 gets loaded into the accumulator. This number immediately after the opcode goes into the accumulator, and these are the two parts. See here, the first part we call it as the operation code, and second part we call it as a memory read. So this M1 and M2 are the machine cycle, and M1 plus M2 together is the instruction cycle. So thus instruction cycle constitutes fetch, opcode fetch cycle, and the execute cycle. After splitting, you can see again the instruction cycle is a fetch cycle plus execute cycle. So here this is the opcode fetch cycle, and the second one is the memory read, and of course this is the result, and there is one clock T transition here. So during that period it executes. So this is how you can remember the instruction cycle, fetch cycle, and execute cycle. So even if you do not understand the total of this, I'm going to I'll provide this MVI instruction timing diagram in your notes. So you observe the diagram carefully, and also you watch the earlier video where I have explained the demultiplexing of the bus, the function of program counter, the function of ELE signal, the function of RD bar signal. So you'll understand slowly how microprocessor execute the instruction by instruction, one after the other, till it reaches to the last instruction, and last instruction is always halt, that is stop. So I think it is time to stop here. See you next time. Bye.